Okay, so the ambiguous case is opposite side is longer, you have one triangle automatically. If the opposite side is shorter and then also shorter than that height, there's going to be no triangles. If that opposite side is shorter than the adjacent, but then longer than the height, so it's in between, there's going to be two triangles. And if the opposite side happens to be exactly the height, that means it's going to be a perfect right triangle. And just one of them. Okay. Then we have, well, what if this angle I gave you was obtuse? So basically, there's only two choices on this one. You're asking yourself, is this opposite side long enough to reach, or it's too short? So this side for sure has to be longer than that one because of the property in triangles. The longest side has to be across from the largest angle. If you do a sine law and then sine inverse, this one will work and this one will make an error. Okay? So on an obtuse, it doesn't matter what we're looking at. There's not a third or a second triangle. There'd be no way, because if that's already obtuse, you can't have a secondary obtuse angle, right? And on the test, you're going to have to fill in one of these full out, get all of that info. So you will have one of those on the test. Okay? So ambiguous, you're going to have, I'm going to give you questions. You're going to have to tell me if there's one triangle, two, and then you'll have to do that. Okay. I picked some of the harder word problems to do with you, because those will be on your test. Okay, so this is where we're flying. We start in Altona. We go to Dauphin. And then we're going to go to Melita. So there's the flights we're taking. Okay, put compass bearings on those positions because we're going to do some angle stuff. Okay, so we are going to Dauphin from Altona. So 305 kilometers. And the path we're taking is north 44 west. North 44 west. Okay, where else can I move that 44? Thinking about our properties of last unit. I can flip it to that side because that's an alternating interior angle. So that's from last unit. After stopping at Dauphin, now we're going to go to Melita. So 215 kilometers. And we're going to be going south 21 west. So when we leave Dauphin, south 21 west. Okay, now my question is going to be about getting back to Altona. This is going to be how far, and we're going to have to figure out our compass bearing yet. Okay, so I'm going to go, what is this entire angle? Now that we have those two up there. So that makes 65 degrees. So when you're working these problems out, your first step is always saying, what are all my angles? What are all my angles? Can I fill in alternating interiors? Can I fill in supplementaries? Anything like that. Okay, what is the situation strategy that we have going on here? SAS. So the cosine law. So 215 squared plus 305 squared minus 2 times 215. So this is the SAS formula for cosine law. Okay, you all obviously have formula sheets with you right now, right? Maybe that'd be a good idea just to get them out so you can practice looking at them and filling that in. Okay, this is the one where we just type, but then what do we do at the very end of this question? We have to square root answer. Okay, so see if you can type that all in. Now we're going to think about this angle stuff. So I want this angle. It's not going to be my compass, but I need this angle. So our strategy now is what now? Sine law pair, right? Can you set up that sine law pair up for me? Bless you. Okay, we're going to have a times, divide, and an inverse, right? When we do those, when you get an angle. So times, divide, and inverse. Okay, so this is 72.7 degrees in that triangle. Okay, so I'm going to get this compass bearing. Okay, so I need this 21. This 21 can do what? It could flip-flop there. When we look at this plus this, do we agree that that's more than 90 right now? Does that make sense? So that's why I know that I'm heading somewhere like that, because it's more than 90 degrees, so I'm past that line. Okay, I'm closer to south, so my compass bearing will be south something, and now that's to the east, right? South something to the east. So how many degrees are in that orange space right there? So we should be doing 180 minus those other ones, right? Does that make sense? Okay, so this is going to be on your test. Okay, so make sure we're doing the flip-flops of any angles we can. You're going to have to use cosine law and sine law all within that question. Okay, a surveyor measuring a lake Okay, we have A and B on opposite sides of the lake. And then we know that they're 1320 apart. Okay, from B, so we're looking from B, pretend that we're standing there. So from B, the measure between the sight lines to the ends of the lake so that means my sight lines to the ends of the lake is, and then that's the whole angle, 129 degrees. Okay, the measure from the angle between when I look at A and the one end of the lake is 96. So we just have to pick an end. So which end do you want to pick? This end or this end? It doesn't matter. So it doesn't matter. I'm going to go with this one. So I'm going to put a star there. So from B, when I look to A and that end, it's 96 degrees. Can you give me this extra angle over here now? So 129 minus 33. Okay. Now we got to put the body person at A. So now we have a surveyor at A. The measure between the angles to the sight line to the ends of the lake. So when they look to the ends of the lake, so that coming out like that whole angle is 43 degrees. I'm obviously not drawing this to scale. So that whole angle is 43. So now from A, when we're going to look towards B and the end that we picked before, that's 15 degrees. So from A, and then when you look at B and that end, there was a 15 degree. Are you getting the one beside it now? 28. Okay, what I'm going to do is my visual, I'm actually just going to separate it right now. Just for, you don't have to, but I'm going to. Okay, let's get the last angle in each triangle. So each triangle is missing one angle. Like I said, I'm sorry, mine is not drawn to scale, but figure it out. Okay, so here's our strategy. We're going to have to think ahead. I'm going to do sine law pairs. And I'm going to call this X and I'm going to call this Y. So I'm going to get an X side and I'm going to get a Y side. Okay, do you see that? So that's what my goal is. I'm going to get that. Okay. Okay, so sine law. let's split in half. How about if you're at the table with somebody, you each pick an X or a Y? And if you're sitting at a table by yourself, just pick one of them. And then, because they're both the same idea here, multiply and divide. Multiply and divide. So just pick one of them to do, and then we'll even it out and get the other answer. Okay, does anybody have anything to offer me here, X or Y? That they're feeling so confident on their timesing, multiplying, dividing?
Y is 821.98.
Okay, Y people? Sounds what you have? Okay. Do I have anybody who is really confident to tell me what their X is? What did you get? 1,300. I got 1,4 something. You got 1,4? What did somebody say? 0.17? Now did you redo it and it came out? What? Are you confusing with the 6, 9, and 9 6s? Because that's kind of, that's where I feel like somebody could type in those numbers backwards. Okay, you don't have to draw this, but I'm just going to show you what's going on. So we just found those two sides. And this is the distance we're trying to figure out across the lake. And what else do we know in that triangle? If we were just taking that triangle, we know what else? We would know the whole angle at the top. So we can see that that is a 43. Okay. Now we got a new strategy. What's going on this one? SAS again. So our formula is the cosine law. Okay, don't forget to square root your answer. You'll probably think of it because your number might be so big that it might not make sense in the context if you forget to square it. Polly's on the ground and she is looking at the top of a building. So that's kind of the situation, standing on the ground, looking up at the top of a building. We can assume that when you do a building that you're making a 90 degree with the ground. So when she's looking up at it at an angle of 36 degrees, an angle of elevation. So from the ground, pivoting up is 36 degrees. She now walks back 28 meters. So back 28 meters. And now she's over there. Oh, this is a bad question. I gotta change this question, I'm sorry. Because it doesn't make sense. We gotta do that. Okay, so I'm going to, sorry, we're gonna put the 41 here. And then walking back, now it's a 36. Okay? Does it make sense when you get closer up to something, your eyes, your head has to tilt higher, your angle's steeper? Does that make sense? When you're really far from something, you don't have to tilt up as much, but like if I'm looking up to the ceiling, if I go closer, 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 my angle's getting bigger, right? So that's why I had a faulty question there. Okay, so how high is the building? The first thing I'm going to get you to do is give me any angles you possibly can using supplementary triangle stuff. Can you get me some angles anywhere in this triangle using last unit's properties? So I would have started here beside the 41. That's probably where I would have started because I can go 180 on that line. Leaving me with did we get a 5 degree on the top corner on that one? And then in this triangle, we should have a 49 degree in that corner. Okay, so that's step one, use all the angle properties we know. Now, I have to use the 28 somehow with sides. So what could I do with this 28? Do we see any pairs? Do we see SAS? Do we see triple S? So I have a pair. Okay, so we're going to pair it with something else. So either the 36 or the 139. So I'm going to do this. You see my pairs that I'm going to go with? Okay. We can't pair 36 with the building. Why can't I pair that and that together? Because they're not inside the same triangle, right? That was two different looking triangles. Okay, can you give me the sine law setup then? I'm going to call it Y, if that's okay with you. So sine law setup times and divide. Okay, 188. Our number's looking okay, matching. I'm going to forget about that triangle now. So concentrate on looking at this triangle. Do you have another strategy now, again, to do something? Trying to get the height of the building. So now I have a pair and a pair. So 2 pairs. So I can do sign law again. Okay, 2 ships are in the ocean and spot a pirate ship. Ship A knows the bearing to B is southeasterly, and the pirate ship is northeasterly. So A has to be over here. Because B is southeasterly and the pirate ship is northeasterly. So does that understand why I'm doing A there? Okay, so when we are going to go to B, south 75 east is us heading towards B. So south 75 east is where B is. Okay, so from A, the bearing to the pirate ship is north 62 east. So north 62 east. And now we have the pirate ship. Okay, B. So I'm gonna go to ship B. The bearing to the pirate ship is north 13 west. North 13 west. Okay, I'm going to do some other stuff here. So let's go, what is beside the 75? What makes that 90? 15 there. What goes beside the 62? Is that 28? Okay, I'm adding to 90 in those corners, right? On a compass, those would add up to a 90. Can we do some flip-flops on the top here with angles? So this would be 62, and this would be 28 if we flip-flop them with alternating. And the 15 would flip-flop like that, right? This would be the 75, right? Can we take off the 13 from the 75? Does that make sense? Because the 75 would flip into that whole spot, but there's 13 that came off. Then the 13 would flip-flop there. So we have a 62 in that corner. Okay, using all those flip-flops, that's what I got. Does that actually add up to 180? Hopefully, right? Yeah, I just double checked. That's good news. Those all added up to 180. Okay, we know that from A to B is 800 apart. 800 feet from A to B, that was in the given. And the pirate's gonna go to the one that's closer. So which ship is closer, and then what's that distance? So which side between this side or this side will be a smaller number? I'm not going to figure them both out and figure that out. What do I know about triangles? Which side would be smaller? Across from the smallest angle is smaller. So this side is across from a 43. This would be across from a 62. So I'm going to use what kind of trig strategy? Sine law. So it's going to attack ship B, because that means that's the path to get to B, right? It's going to go on this path, which means it's going to attack ship B. Okay? So on the trig side, this would be the easiest, but this was the hardest on flipping all the angles. So you really have to be careful on that question on your test. Get all those angles using your properties. Okay?